E, for example, on this thing, right? What is E? E. I think that's E. Right, so if you want to show this A, for instance, on this 25/7 what are you going to send to the microcontroller? Remember these lines over here, let's say for example this is port B, right? And this is port B 0 to 6, right? So this will be RB0, this will be RB6, right? You'll notice that this takes in almost an entire port quality, right? This takes in almost an entire port quality. It means therefore when you tell or send this to the output, right? When you send the value that is required for this thing in the output, for example, let's look at this over here, right? Take the top-down approach. Yeah, so we'll be using RB7, for example, if this was like 8 port, right? So RB7 would not be connected, right? So RB7 is not connected to our system here right now because we're using from 0 to 6, which is 7 lengths, right? Although it's not connected, we can still, let's say we're sending 0 to it, and let's assume that 1 is to actually turn on, 0 is for on, right? So 1 is a high and 0 is a low, right? So having that now, we can see, all right, well, let's break this up into 2 neighbors, right? So we have our first one with 0, 1, 1, 1, right? Then 1, 1, 1, 0, right? So this is the value in binary that we need to send to our port B, right? Right? So the value in binary that we need to send to our port B, which is connected to this output, would be that. But that value now only controls this first line, this first column.
So
right? Huh?
But RB7 is
RB7 is not connected.
so
Remember, we have 8 bits. Oh, why bit 0?
To make the 8 bit.
Yeah, because just to complete the signal that we're sending.
Because with the 1 still, it won't show up.
Yeah, it wouldn't show up. It wouldn't because it's not really connected. But just to right? Yeah, 0, 1 it doesn't really matter, but let's just send a 0 because we'd rather have it be a dead pin than having it be a live pin. Right? What if somebody touches that sorry, what if something else interferes with it or whatever? So let's just kill the pin and send it and give it a 0 potential. Right? So that is not really anything of importance right now at this point. If you were to look at it in terms of hexadecimal, we would need it to give this thing a value. Right? So the fact that we're using binary or hexadecimal, what have you, we're working with 8 bits, we need to put all the bits there. Right? Give it a value, 0, 1 or whatever, but we need to assign something. Next thing, how are you going to see, well, this one is on when all the others are off. Right? There are a number of different approaches that we could use. We could use, for example, we could connect this entire thing, to, let's say, port C. Right? So this one is connected to port C. So what we can do is each time in each iteration, in each loop, so to speak. Right? So we start off this thing as saying the first one that we want on in our program, when we send this value, when we send in for column 1, we send for column 1 this value, we want to activate column 1, right? So we could actually say here at this point, the next line of code, column, so this would be port C 0, 1, 2, 3, 4, port C 4, right? So we're moving in that direction here. Remember I said we could also use the rotate, right? We could also use the rotate. So we initiate our port C with the value, for example, 1, 0, 0, 0, 0, 0, 0, right? We could initiate it with that value, meaning that we only have one high pin, right? We only have one high. What we do now with each iteration, each time that we send the next value, we also tell it to rotate, right? Somebody pass the ticket. Yeah. Alright, the other person pass the ticket didn't say anything, you know?
Yes, sir.
Right? So we could also tell it to rotate to the right, right? So we tell it to rotate to the right. So in other words, what happens now is for the next iteration, this becomes, so we pick up, let's say for example, our 0 pushes over here, and we pick up the 1 coming here, and this becomes 0. Which means here that the first one, when we started, this was 1, this was 0. It now means that when we push this over, this becomes a 0, this becomes a 1.
A shift.
Yes, it's actually known as a logic shift.
Yeah, logic.
Right? It's a logic shift. That's exactly what it is.
A logic right shift.
Yeah. Right? So that's exactly what you're doing here. You're just shifting that bit, or shifting that higher value one bit. Right? So that is one approach. Another approach which is also common is if we're using, let's say for example, we have limited ports on our microcontroller. We don't have a microcontroller which is as flexible as the one that we have, or let's say for example the microcontroller that or the number of segments that we have, the more segments that you have, the more ports that you're going to require if we're going according to that method, right? If we're using that method. What we may want to do is to use, let's say for example, a Johnson counter, right? So the Johnson decade counter, what it does is it allows you basically to use that same scenario in terms of like a counting. So it moves the bit 1, right? But it actually counts like a binary count. It performs like a binary count. Now when that happens, is basically it's an IC. It's a little IC counter that you also complement your circuit with. Alright? So by connecting it now, each time it moves, but the problem with that is you have to make sure your timing is accurate. Right? So you have to perform your calculations and stuff for your timing, because you don't want, let's say for example, when this thing, when the counter jumps to the next value over here, we haven't really cleared, for example, the column that we want. When that is not done properly, what you may see happening is 2 columns might show the same thing at the same time. Right? Or even more, if it's done wrong. Right? So you have to make sure that the timing is correct, that only one column of that column is activated when your counter is at that point. Right? And one of the problems with that too is at times you may want to use like some capacitors or so to even help with the circuit, reducing noise, etc. These obviously, they will store a little bit of charge. The time taken for the discharging we will actually see in your 7-segment, dot matrix display. You may see probably like a ghost LED light in the background. Right? So let's say for example all you want to see is the letter A showing up. You may see a ghost light for 1 or 2 of the LEDs like dim in the background, but you can tell that this LED is kind of on. Right? Huh? You see that make out difference? Right? So that is where we have this little discharge and stuff still there. Right? There is another method that you can use, and you would use it with what is known as a shift register. Right? So you can also use shift registers to accomplish the same thing. Again, the task is going to be similar. Right? One of the advantages of using the shift register is that you are able to, let's say for example, connect much more of those little segments than you would probably be able to accomplish using these other methods. Right. Guys get that?
So repeat on yourself what she says.
Okay.